Okay, for example number 4, again, we are still on section 3.6 part 1. So this is my 4th video. So I'd really like to get these last 3 examples in just this one video. So that gives me 5 minutes per example. So especially for this midpoint rule, since it is so tedious, so long, I'm going to pause a couple of times and then just write out everything and then start again. So when you're watching this, if you're really trying to follow along really closely, then go ahead and pause and just do some comparisons. Make sure you understand where I'm going with every part of this problem. Okay, so using the midpoint rule with n equals 3 to approximate the integral. So we've got quadratic equation. And if we factored this negative x out, we would have a 2 minus x, so 2x plus x. That means we're going to have a 0 at 0 and at negative 2, and it opens down. So this tells me that my integral, and we're going to go from 10 to 17, so that's going to be way out here. We're just going to put them right here for this case. Say we have a little break in our line there. But main point here that I want you to see is that we are going to have a negative answer since everything is underneath the x-axis. So let's find, we know that n equals 3, so delta x is going to equal 17 minus 10 divided by 3. So each interval is going to be a width of 7/3. We need to write down what our endpoints are, and I think this is very important for your midpoint rule, is to write down what those endpoints are. So the endpoints are going to come from our delta x, and we're starting at 10. So we're going to list our endpoints, then we're going to list our midpoints and find all of those. So we're starting at 10, so 10 is our first endpoint, and then the next one is going to be at 10 plus 7/3. I'm going to write them all out this way, and then we'll go back and calculate them. And I'll just pause as I write all those down. So 10 plus 2 times 7/3 is another endpoint, and then the next endpoint is going to be 10 plus 3 times 7/3. Now this one's pretty easy to calculate. Our 3's are going to cancel, and then we're going to have 10 plus 7, so that is 17, and that is my last endpoint. So those endpoints equal, I'm going to pause and write them out real quick. Okay, so just by calculating those values that I had listed up here, now we have these for our endpoints. Now our midpoints are going to be halfway between each one of these intervals, and it's going to be half the distance of our delta x, so because we want to be right in the middle of that distance. So we can take our delta x, 7/3, multiply it by 1/2. That's going to give us 7/6. So we're going to be 7/6 units away from each left-hand endpoint. So our first endpoint is at 10. So our first midpoint is going to be at 10 plus 7/6, which is half of delta x. Okay, so that's going to be my first midpoint. My next midpoint is going to be at 12 1/3 plus 7/6, and so on. Then 14 2/3 plus 7/6. And then we're not going to have a midpoint after our last, after 17, right? We're not going to have any points out here. So when we get to 17, we're just done. We're not going to add 7/6 to get that again. Okay, so I'm going to pause, calculate those, write them out, and then I'll be back. Okay, so I went ahead and added those, 10 plus 7/6, 11 1/6, added those all up as mixed numbers. I also then changed them into improper fractions so that it was easier to put in. Then I went into my calculator. I put y equals negative 2x minus x squared. Then went into my table, entered in these very lovely improper fractions, 67/6, 27/2, and 95/6. Then I took the values from each one of those, add them together, multiplied by 7/3. So remember, our midpoint formula is that we multiply by delta x, because that's going to be the width of each one of our intervals. Okay, the delta x is the width, and then the f of x, the function, is going to be the height at the midpoint of each one of our intervals. Okay, midpoint height. So each one of those is going to be the height, then times the width, and then that will give us the overall area of that equation, and then that is the correct answer for example number 4. Okay, next example is the trapezoid rule. We're going to do the integral from 1 to 3 of cosine x over x, and this time we have n equals 5. So if n equals 5, let's find delta x. Delta x is going to be equal to 3 minus 1 over 5. And so 2/5 becomes our delta x. So on this one, we need to know what our endpoints are. Don't have to worry about midpoints on this one. We just need endpoints, but endpoints are very important. So let's go ahead and list those endpoints. And these are our x terms. Now if we looked, I would go on Desmos and graph this equation, which is what I did, and it looks like this. It comes back up, and then I think 3 was like right in here somewhere. So we go from 1 to 3. So we're going to have some parts of this equation that are negative, some parts that are positive. We need to have 5 intervals. So let's see if I can get 5. 1, 2, 3. Oh, that didn't work. 2/5. Well, we'll figure out what our endpoints are, and then I can come back and put those in there. Our halfway mark is not going to be one of them. But let's go ahead and list our endpoints, and then we'll go back and make each one of our intervals with our trapezoid rule. So our very first one is at 1. We're starting off at 1. That's our first endpoint. So where x equals 1. Okay. Our next endpoint is going to be 1 plus 2/5. Next one is going to be 1 plus 2 times 2/5. And so on until we get all the way up to 3. So 2, 3, and 2/5. And then 1 plus 4 and 2/5. And then the next one is going to be 3, because 5 and 5 are going to cancel. And then 1 plus 2 would be 3. So let's go ahead and end that there since we're out of room. Now all of those endpoints, I'm going to just pause and write those out. Okay, I went ahead and found my endpoints. I found them in 2 different ways. I found them so that they were mixed numbers. Also found them so that they were improper fractions. That can help me in 2 different ways. The mixed numbers helps me to write, so you can notice here I went ahead and did all of my intervals so that I have my 5 intervals. So that helps me see my graph and what I'm looking at. And then I am going to use the mixed numbers to actually find my equation. So remember, with our trapezoid rule, the area of a trapezoid is equal to 1/2 times the height times base sub 1 plus base sub 2. Remember that each one of our sides in this case are going to be our base sub 1 and our base sub 2. And so when we do our trapezoidal rule for integrals, that's going to be t sub 5 in this case because we have 5 subdivisions. And so we're going to have the 1/2, which comes directly from our equation, times h. Remember that that h in this case is going to be our delta x's, and our delta x is 2/5. Then with our bases, our first base is only going to be used once. That's the left-hand endpoint, and the function, the f of 1. Then plus 2 times f of 7/5. Plus 2 times f of 9/5, and so on till we get to the end. Pause this. And okay, so I just went ahead and finished that one out. So our trapezoid rule, 1/2 times delta x, which is 2/5, the 2's cancel, we come up with 1/5. And then we have the f of each one of our endpoints. Add them all up. The first and the last are going to have a coefficient of 1. Everything in the middle is going to have a coefficient of 2, because all of those sides are going to be used twice in each one of those trapezoids. So then we find f of 1. I went in, I put cosine x over x into my calculator and used my table. Put in 1 for my table, 7/5, 9/5, all of those. Then I found that information, added it into my equation, added them all up on my calculator, and I ended up with negative 0.19874. And that is my solution using the trapezoid rule for that example. Okay, this time we are going to use Simpson's rule given a table of information. And this is why Simpson's rule, all of these rules are important that we can use, because sometimes we need calculus, but we're only given a certain set of information. So one thing that we need to make sure is we need to make sure that our x values are all continuous and evenly spread apart. So we have 10, 11, 12, 13, 14, 15, 16. That's really good. Also notice that our delta x we can find just from this table. So delta x is going to be equal to 1, because that's the difference in each x value. Also notice that when we find our intervals, our subintervals, that we look at them this way. Don't just count your data set, because you're always going to end up with one more. So we have 1, 2, 3, 4, 5, 6 data values from endpoint to endpoint. We're going to have 6 subintervals. Okay, so n is equal to 6. So just remember that n is always 1 less than our endpoints when you're looking at a set of data like this and they don't give you the n information. We could have done delta x as b minus a over n. You should get the same answer, so 16 minus 10 over n, which is 6. And that would be equal to 6 over 6, which is 1. So either way that you come up with that answer, just be really careful that you're paying attention to how many subintervals that there are. So we are going to use Simpson's rule on this one. So we are going to do S sub n is equal to delta x over 3. So delta x is 1 in this case, over 3. That's part of the over 3 is part of our equation. So remember that. And then remember with Simpson's rule, we're going to have our first one has a coefficient of 1. So we're going to have f of 10 plus 4 times f of 11 plus 2 times f of 12 plus 4. So remember, we're going to alternate that 4 and that 2 until we get to the last term. And then on the last term, we are going to leave our coefficient as 1. But remember to alternate those coefficients before that. So f of 16. All right, so we've got it all set up. That's what our formula is on this one when we have those data sets. Really nice, because now we know exactly what f of 10 is. F of 10 is 0 plus 4 times negative 9 plus 2 times negative 7 plus 4 times 2 plus 2 times 9 plus 4 times negative 9 plus 1 is our coefficient there, so just 6. Okay, and then once you look at all of that, add all of that information up. I'm just going to double check, make sure I wrote all of those correctly. Okay, looks good. And now add all of those up, divide by 3, do all of your algebra in there. You're going to end up with negative 54 over 3, and that all equals negative 18. Now if we go ahead and integrate this equation, actually we can't. Yep, nope, that's not going to work. Just negative 18 is all that we can do on that one. Okay, barely made that video in time, but that's all the examples that we have for section 3.6, and I hope that if you have any questions, you'll let me know.